will determine the angular velocity and the angular acceleration of a rotating fan, securing a phone to one of its blades to obtain the circular motion in the y-axis.
The research objective is to determine the angular velocity versus time behavior of a rotating fan, as well as determine its angular acceleration versus time.
Next is the procedure. First, we secure the cell phone to one of the blades of the fan using cinches. Secondly, we turn on the fan to get data from the axis. Next, we multiply the result times 9.81 to find the acceleration in units meters over seconds squared.
The next thing we do was to find the angular velocity using the formula W equal square root of radian acceleration over radius. Then we calculated the angular acceleration using the following formula. Acceleration equals to the difference between velocities over difference between times. Finally, we graph the angular velocity and the angular acceleration both in function of time. We download the app accelerometer. The cell phone was placed on one of the blades of the fan and we secured the phone with plastic wraps. We measured the radius, that is 12 centimeters.
The theory and data we used for this project was the next functions. S of t equals radius times theta of t. The derivative of s of t equals derivative of radius theta t. V equals radius derivative of theta t. The V equals RW relationship between linear and angular speeds. Tangential component of acceleration. The tangential acceleration equals to derivative of V equals derivative of R times W equals to R derivative of W equals R times acceleration. The tangential acceleration equals to radius times acceleration. This is the component of acceleration magnitude.
Centripetal component of acceleration. The radian acceleration is equal to velocity square over radius, and that is equal to r times w square over radius. The radian acceleration is associated with the change of direction of the particle's velocity. The centripetal component always points towards the axis of rotation. On the other hand, the tangential component of acceleration is equal to the derivative of velocity, and velocity is r times w. So the tangential acceleration is equal to r times a. That is the component of acceleration magnitude.
These are the graphs we obtained from the results. The first one is the angular velocity in function with time, and the second one is the angular acceleration in function with time.
We will recommend to take the y-axis for you to find the acceleration. Also, make sure the phone has been secured properly. Multiply the data from the app to make sure you are using the correct units. And finally, multiply the angular velocity times -1 in order to have a positive square root.
Our conclusion is that the angular velocity and the angular acceleration of a rotating fan. As a conclusion, the angular acceleration can be calculated with this formula. W equals to square root of radial acceleration divided by r. We found out that the y-axis is the one that is modified when the fan is in motion.
We took the information from our physics lectures as references.